Alright, in this video, we're going to take a look at another really important idea, the zero product property. As I said before, factoring is super important to algebra, and it's a skill that's always useful. And one of the hugest applications of factoring is solving equations involving polynomials, where you have to factor and then use the zero product property to solve the equation and find what x equals. So what does the zero product property tell us? Well, in words, it says if the product of two factors is 0, then at least one of the factors must be 0. So I'm saying if two things multiply together and they equal 0, one or the other or both must be 0. So what they have, if a times b is equal to 0, where in that case we're saying a is some number, b is some number, or expression. But it's two things that multiplied together equal 0. Then either a equals 0 or b equals 0. And that's because anything multiplied by 0 is 0. So case 1, suppose a equals 0. Well, then I have 0 times b is equal to 0. And no matter what b is, b can be anything. This is just going to equal 0 because 0 times anything is 0. So that's case 1. Case 1. Case 2 is, well, what if b is 0? Then I have a times 0 is equal to 0. Well, again, a can be anything, but if it's getting multiplied by 0, it's all just going to equal 0. This equation works out because 0 equals 0. So if a equals 0, or case 2, b equals 0, well, what about case 3? If both a and b equals 0, it's 0 times 0 is equal to 0. Well, that's clear as 0 equals 0. So either one or the other or both can be 0, and it all will equal 0. All right, let's see how this plays out, because a and b are not just going to be single numbers here. They're going to be more expressions. They're going to be the factors of our polynomial after we factor it. So example here, I say solve x plus 2 times x minus 3 equals 0. And because our expression is factored, it's a string of things that are multiplying together. So in this case, I have two things being multiplied that equal 0, like my a times b. The zero product property says that either x plus 2 equals 0 or x minus 3 equals 0. Those are my two options. And either one leads to a solution. Because what if x plus 2 equals 0? Then what does x equal? Well, solve this for x. You subtract 2 from both sides and you get x equals negative 2. So there, if x is equal to negative 2, this equation up here should work out. Well, what happens? If x is equal to negative 2, I have negative 2 plus 2 times negative 2 minus 3 equals 0, which there in that case, negative 2 plus 2 is 0. 0 times negative 5 is equal to 0. 0 equals 0. So you notice if x is equal to negative 2 and it caused the whole thing to equal 0. That was just one scenario. That was if x plus 2 equals 0. But I have the other factor, x minus 3. What if that equals 0? Well, solve this for x then. Add 3 to both sides and you get x equals 3. So if x equals 3, this equation up here of x plus 2 times x minus 3 equaling 0 should also work out. Well, does it? What if x equals 3? Then I have 3 plus 2 times 3 minus 3 is equal to 0. 3 plus 2 is 5. 3 minus 3 is 0 equals 0. Well, 5 times 0 is just 0. Boom, the equation works out. Hey, so x equals 3 is also a solution to our equation up here. And what does that mean for the solution here, for what x equals? Well, x can have two values. X can equal negative 2 right here, or x can equal 3 from our other factor. So x equals negative 2 and 3 is our solution to that equation there. Again, we have one already factored. I notice that it's something times another thing equaling 0. A times b equals 0. Well, the zero product property tells me that if I'm trying to solve for d, either 2d plus 6 equals 0, or 3d minus 15 equals 0. One or the other of those factors has to equal 0. And then from there, I figure out, well, what does d equal? Because that's the ultimate question here. We're trying to solve for our variable. What does d equal to make this equation work? So then I go through and solve these for d. Subtract 6, and I get 2d is equal to negative 6. Divide by 2. Divide by 2. So d is equal to negative 3. So if I were to plug in negative 3 in for d in our equation, one of those factors, the first one, would equal 0. Therefore, the whole thing would equal 0. So it's a workable solution. But then don't forget about our other factor. I have 3d minus 15 equals 0. So I need to solve that for d. So I add 15, and I get 3d is equal to 15. I divide by 3. D is equal to 5. I plug that in, and it's going to make the second factor equal 0. Therefore, the first factor times second will give me 0, and 0 will equal 0. I encourage you to plug those values in and see if it works out. But again, I have two solutions here. D is equal to negative 3 and 5. Both of those, either of those values that I plug in for D, will make the equation work. It'll make the left equal the right. All right, look at this one. We have the equation c squared equals 3c. Well, what does c equal? We have to solve this with the zero product property. Notice an important part of the zero product property is it's if two things multiplied together equals 0. This only works if the equation equals 0. If the one side of the equation equals 0. In this case, I have c squared equals 3c. I can't just say, well then, c squared equals 0 and 3c equals 0. No, the first thing you have to do is set the equation equal to 0. So I'm going to subtract 3c from both sides, which on the left, there are no like terms, so it's c squared minus 3c. Can't combine it, but now it equals 0. That's the first step here in solving these equations with the zero product property. And you're going to use the zero product property anytime you have a variable with a power greater than 1. See that c squared? That's going to lead us to believe we should solve this by factoring using the zero product property. So now that I've set it equal to 0, well, again, the zero product property says if two numbers are multiplying together to equal 0. So they can't just be adding or subtracting like we have here. It has to be two things multiplying. And how do I get multiplication? We factor. So I factor out a greatest common factor, which is c. And I'm left with c times c minus 3 is equal to 0. I now have two things being multiplied together and equaling 0. So I can think of those as like the a and the b. So that means by the zero product property, I can take each factor and set it equal to 0. So c equals 0 or c minus 3 is equal to 0. Well, this one's already solved for me. Didn't have to do much work there. Over here, I'll add 3 to both sides, and I'll get c is equal to 3. So the solution is c is equal to 0 or 3. Either of those values for c will work. All right, one more problem to round it out and practice our skills here. I have the equation 8b squared equals 40b. Now again, because I have a variable with a power higher than 1, kind of clues me in that I have to solve this by factoring. I can't just set this equal to b and solve it because I have a b squared there. It makes it more complicated. So I'm going to rely on factoring in the zero product property. And as we said, the first thing you have to do when you solve by factoring is set it equal to 0. Because the zero product property only works if the equation is set equal to 0. So I subtract 40b from both sides. Now I have to factor this. So I factor out a greatest common factor. And out of each of these, I can pull an 8b. And I think, what's left over if I pull out an 8b? Well, in the first one, I have just a b left over. In the next one, I go and think 40 divided by 8, well that's 5, so if I factor out an 8, I'm left with a negative 5, and I'm also pulling out this b, so he's gone. So I have 8b times b minus 5 is equal to 0. Now by the zero product property, because I have two things being multiplied to equal 0, either 8b must equal 0 or b minus 5 equals 0. And then I solve those for b. Divide by 8, divide by 8. Well, 0 divided by anything is just 0. So b equals 0. And on the other hand, I add 5, b is equal to 5. So the solution to this equation is b is equal to 0 or 5, using the zero product property.